Good morning, students. Yeah,
Good morning, sir.
good morning. Hope all are doing well. And I still find some people joining from outside karunya.edu. Kindly request you to join via online.karunya.edu only, so that I need not come back again every time and allow you to enter the class. It will be easy for you and also for me. Hope all of you are doing well, and we were seeing some basic introductory concepts about the subject machine learning, and I will give a brief overview of what we saw in the previous class. We saw that there are three types of machine learning techniques. One comes under the category of supervised learning, the other comes under the category of unsupervised learning, and then we have the reinforcement learning. Whatever algorithms or whatever methods you choose, it should fall under any one of these categories. And in the previous class, we saw that supervised learning needs the support of a label or a target data. That means whenever you have a data, the name of the data also should be given during the learning process. So the machine takes the data and the name of the data, and then it learns. So because of this learning process, we say that it is more accurate in the sense that we have a concept of this target or label. So whatever output we get from the machine, we can compare it with our target and check whether it is correct or not. If it is not correct, or if there is some error, we ask it to adjust the error by some algorithmic procedures, which we will be seeing later. And this process will keep on continuing till your error becomes zero. So this is the main idea or concept of any supervised machine learning approach. So when the error becomes zero, we say that all the input data are learned by the specific supervised learning approach, and then we go for the testing, right? Learner and reasoner. Then we go for the testing by giving a unknown data, and that data will be able to that data will be processed by the machine depending on the application, and you will get your. So this is the concept. Maybe if you have missed that, you can go through the PPT which I have uploaded in the Google Classroom also. And more importantly, it is normally specifically used for classification and regression applications. So you must be very careful in choosing an algorithm for your approach. Classification. It is all about saying that whether this is A or B, or whether this is hot or cold, anything of that sort, classifying. Our output will be in the form of a linguistic sentence, an English language. But when you say regression application, your output will be in the form of a number. So it's like an equation where the variables of the equation changes, you will get a number. So you need to, the user or the programmer should be able to categorize their application into either the regression or classification. The algorithms or the process which we are going to see later almost remains the same for the approach, except for the application point of view. We saw some applications also: face recognition, gait recognition, fingerprint recognition, biometrics. Most of them comes under the category of your supervised learning. Right? So unsupervised learning, predicting the weather, predicting the financial situation, or any other prediction based applications where you're going to get an output in the form of a number, comes under the category of regression. So this is what we saw in the last class in a nutshell. Now today in this session we will be looking at the concepts of unsupervised learning. So remember, this first unit is completely about the basic concepts, the broad idea of machine learning, which are very important for you to do some experiments with these learning approaches, or even to find something new when we go into the algorithmic concept. So today we will be seeing about the unsupervised learning approaches. Is my screen visible?
Yes, sir.
Okay.
Yes, sir.
So now we will go into the concept of unsupervised learning. So training and learning both are the same words, right? In same words, in the sense it corresponds or it gives the same meaning to the machine learning approach. Right? Training is more of a technical word. Learning is more like a word which we use unofficially, right? But both corresponds to the same. So what happens in unsupervised? It is exactly like something like the opposite features of what we saw in the supervised learning algorithms. Right? In unsupervised learning algorithms, no labels are given during the training process. Right? So when no labels are given, right? When no labels are given, it is a bit difficult for you to learn. Say, for example, you have plenty of notes before you, but you have not pasted any labels on that, saying that this is history note, this is social note, science note, or something like that. Now, when you look at your notebooks, right, it will be not easy to find out which one belongs to which category. Now the question is, are we purposely not giving the labels? No, it is not like that. There are some applications where we will not be able to find the labels, right? We will not be able to find the names. We will not be able to find out the actual detail of that specific data. We ourselves will have some confusion. In that case, we are not able to give the data labels to the data. So can a machine learn even for such type of data? The answer is yes. For that, they framed a different category of training algorithms or learning approaches, which we call it as unsupervised learning. If you have a data, then there is no question, you can immediately go into, sorry, if you have the label and the data, you can go into supervised, or you should come under the category of unsupervised training algorithms, right? So if there is no data, no label, what the machine learning is going to do, right? It is going to find the structure of the data on its own. What do you mean by structure? Shape or the patterns, right? Say, for example, I have plenty of notebooks before me without my labels. Say, for example, I have an English composition note. Have you seen a composition note? Anyone from the group? Composition note? Composition note be maybe when I was studying, there was a concept like English composition, Hindi composition, and Tamil composition. Have you seen anything like that? That yes.
Yes, sir.
Can you tell me the difference? How do you say that? The shape of the composition note will be uh,
Long and
yes, yes,
slim.
exactly, right. It will be the shape, it will be something different from what you have in a normal 200-page notebook. It will be long. Nowadays, you have many notebooks in a longer shape, with a longer size or shape. But previously, all our notebooks will be only small. Only these composition notebooks will be having a bigger size. So what my mind, when I see that, when I don't have a label on my notebooks, what I find is, okay, this is going to be the composition notebook based on the structure or the shape which I'm going to find out. Okay. The next question is, when I want to find out Hindi notebook, Hindi composition notebook, I will not be knowing that what is Hindi composition notebook, but I know that the composition notebook has a specific structure, which technically we call it a similarity measure. Right? So when one English composition notebook I am able to take out, the Hindi composition note should be also with the same size and shape. I do not know which one is English, which one is Hindi. That's fine. But I can categorize the data. I can group the data into some specific groups. Okay, then randomly I will pick one and write English and one Hindi and one Tamil. Right? So this is the way how a human being is going to learn with complete information is not given to him. We are going to find the structure or the shape or the pattern in the data given to you based on some similarity measures. That is the idea or concept of your unsupervised training algorithm. There is no target. Why no target? When there is no label, there is no target. Or the other word for target is your desired response. Desired response from the machine. It is not there. But interestingly, if you go deeper into the analysis of supervised and unsupervised learning approaches, most of the time our human brain works in an unsupervised manner only. All right. When you go when you travel by the roadside, suddenly you see a hospital or a police station where the paintings of the wall will be having some similar characteristic features. Right? If it is a police station, they may have a patches of white and red or something like that, some specific for the building. Take a post office. They have some specific paintings or structures. At the time, nobody come to you and tell you that this is post office. Right? You, based on your previous past history of data, which has some similarities, to this building, then you come to a conclusion that it is going to be actually a police station or a post office. In most of the applications, we lack in real-time data. The labels of the data are not given, but our human brain has the capability of grasping things and come to a conclusion. But it may be wrong also, right? It may be wrong, or sometimes I may misjudge a police station for a post office also, right? But when you have a supervised, it is more accurate. But interestingly, our brain works more like a unsupervised learning methodology. And the fourth point is it cannot classify the input data. We saw supervised learning approaches are useful for classification. They will tell you 100% this is a duck, this is a cat, this is a toy, this is a mobile phone. But here it cannot do that because it is not having any naming details with it when it learns. But what it can do is it can group all the different input data. It can group the Hindi composition node, Tamil composition node, and English composition node into a specific category or class. Right? That word, that concept is technically called as clustering. If you are referring some websites or with machine learning, they would have often used this word called as clustering. Right? Clustering means grouping. If you ask another person what is classification, that also they will say grouping. Both look same, but they are different. Classification means, yes, it is grouping, but identifying the specific nature of that data. Not only saying that these are composition nodes, saying specifically that this is Hindi composition node. But when you go for unsupervised, it is only grouping where you are going to have some similar data in a specific class or a group. So you must understand the difference between the clustering and classification. So this is how the training process will go on in an unsupervised approach. Do you remember the difference between supervised and unsupervised approaches, or do you remember the diagram which I gave you in the previous session? If not, you look at this. This is for the supervised one. So what is the difference between these two? When you go for an unsupervised, I have a data. Right? Without data, machine cannot learn. That is 100% sure. But the difference is the second block in this diagram, which is nothing but a known response. The names, the labels of the data is not there in this unsupervised mode. Right? So again, I'm going to give the same process. I have an algorithm or a method in which the computer, with which the computer is going to compile all those things. And finally, it is going to give me a model. It's not a program, it's a model. Face recognition model, date recognition model, any medical image recognition, satellite image recognition, all these are models. So with these models, what it is going to do, when I give further a data, right, what it can do is it can only give a response by grouping all the data which are similar. So the similarity measure plays a major role. But when you go for this one, the similarity measure is not necessary because we know clearly. So this shape, a round shape with a needle-like structure, definitely it is going to be a spoon. Right? But here you cannot have that flexibility. It is only based on the similarity between the objects where your data is going to be grouped. If you want, you can take this output, again do some post-processing, and then you can tell that this is spoon or this is. It depends upon the users. does not have the concept of error. So if there is no target, when you do not have the target, our process or our main concept of supervised learning approaches cannot be used here. It cannot be used here, right? Because we had the flexibility of target, we told that target minus output is your error is equal to something. So you change, keep on changing your some with the help of some algorithms until your error becomes zero. When your error becomes zero, that is fine. Your output, your required output you have got, that means the data is stored. That concept completely fails when we come into the unsupervised mode. It does not have the concept of error. There is an adjustment process. For the time being, you forget the word wait, right? It need not be given to you now. There is an adjustment process which is not based on the error, and it's performed in a different way, right? Not based on error. There is a different way by which we are going to execute the program to make sure that the computer learns your data. Right? So this unsupervised training algorithm can be also termed as a concept of a student learning without a teacher. A student learning without a teacher, something equivalent to the distance education, where they will supply you only the textbooks, right? Or an online coaching from coaching centers, where you can get only the textbooks like our Akash or Brilliant. Many coaching centers are there. You get only the textbooks and you need to learn on your own. That mode is also available. But what happens is a teacher will not be there to guide you. So the only difference is when a teacher is there, it may be accurate. I am not going to say that all teachers are going to give you the complete, but ideologically we say that teacher helps you. Teacher, with a teacher, you can learn better than learning without a teacher. So the accuracy is the major difference between supervised and unsupervised learning approaches. So if you need an application like a medical image analysis, where they will try to find out the tumor in an image, right? Normally, when the patient comes, he will be asked to take a scan. MRI machine will be there. The image output will be obtained, and it will be given to the computer. The computer is going to execute your machine learning approach, and finally it is going to give you an output whether he is having a tumor or not. So when in such applications, your algorithm should be 100% perfect, right? Because even when a single tumor portion is missed out, we may say that you are free from the disease, but that tumor may grow and spread to other tissues, and the result may be fatal. So accuracy is very important for such applications. In some other applications, such as watching a movie, right? The video clarity is there, right? Even if the video clarity is not that great, nowadays you can see that Sony, they say HD TV and all those different types of clarity resolutions, burn, curved, and many other different shapes are there. They say that clarity is more, but still that also can be viewed in a normal TV. Doesn't make much difference. So in that applications, you can go for unsupervised mode. If you have any training process, that can be done. So again, it is based on the application. We have some issues with unsupervised learning, as we saw in the supervised learning also. How do we know if results are meaningful, since no answer labels are available? Right? Interestingly, in supervised, I will say that it's a spoon, but here I'm going to only group everything together. So when I'm grouping everything together, say for example, I'm grouping all the girls and the boys, right? In that case, girls and boys, fine. Nowadays, you can see that boys having long hairs. They are having some clips, and you see so many of the cricket players, they have all those things which are used by girls, right? And girls, on the other hand, they are wearing jeans, t-shirts, and all those stuff. Whether will I get a confusion or not? There is a chance. There is a chance, because I do not know, I do not have any labels with me. So whatever result we are getting out of an unsupervised learning approach, we cannot say that it is completely correct. Okay? We need some experts. After doing some experiments, I should go to an expert for external evaluation, which will be very complex. Doctors, they will not much more comfortable with the machines which we make. They think that whether we are going to replace their job, or whether they think that whether a machine can do a better work than a human being. That is their ideology, right? So that is not that easy as you think. And again, the similarity measure, the selection of similarity measure. Right? How do you categorize spoon and knife? What specific characteristic feature I find between these two? That is very, very important. If you plainly take some similarity measure, then there is a chance that spoon and knife may come under the same category. So all unsupervised learning algorithms will have an objective function, or we call it as, these are technical words which you must know. Right? Objective function is equivalent to a similarity measure. Right? How you categorize these two things together? A mobile phone and a notepad. How do you put together? Or whether you are going to have it in a different group. That depends upon the user. That depends upon the similarity measures which you choose. Right? When they go wrong, then there is high chance your entire output may go wrong. But these problems are not seen in the supervised training approaches. Right? But still, why it is going to be necessary? Right? The first one is annotating. Right? So please note down all the technical keywords which I'm using. That we are going to use that a lot in the coming days. Annotating. Right? Annotating means annotation. We call it as annotation in the sense that naming the data set, naming the data set, or giving labels to the data set. Right? Spoon and knife, it is very easy for me to say that this is spoon, this is a knife. But you assume a crowded mall. You take our Brookfield Mall, you are going to a mall. Right? How many people will speak simultaneously? How many people will speak simultaneously? Plenty. Or you assume that you are listening to a cricket commentary in a cricket field. How many people will talk? How many people will create noise? In that case, if you want to mimic the same situation to the machine, how can you assign the labels to each speech signal? In a mall, there may be 20 people or 30 people, right? Annotating everyone is not that easy. So when you have a larger size data set, having labels is very costly. We say it is computationally expensive. Costly means it's not giving money and getting computationally expensive. It takes lots and lots of time to give labels before going into the actual concept. Say, for example, you take our emotion recognition concept, a positive emotion, negative emotion. Nowadays, in WhatsApp or Facebook, we use lots of emojis, right? Or even in Signal. Nowadays, people are shifting towards Signal. We use emojis, right? With emojis, you can say that you are laughing or you are crying or you are sad. That is fine, right? But when a machine wants to recognize, right, how will it find out whether this is a positive emotion or a negative emotion? A burning building is a negative emotion, right? A person crying is a negative emotion, but there is no relation with a building and a person crying, but they come under the same category. So labeling is a complete research area that itself takes lots and lots of time for you to label it in a clean way. Right? Say, for example, in license plate detection process, you have vehicles, traffic is there. When somebody is violating law, we need to find out their number plates. At that time, how we are going to do? First, we need to label. We need to find out all the alphabets and the numbers. Only then we can say this and this car has violated. So that itself is a huge process. So if that is the case, then people think that why should I waste more time on that? Let me go into an unsupervised, even though there may be a loss of 5% or 4% accuracy, that may be fine for me. People think like that for some applications and they go to unsupervised. And as I told you earlier, there may be cases where you do not know exactly how your data should be, or whether spoon is there or knife is, the names will not know. Or sometimes you do not know how many classes you have. When I say spoon and knife, you will know that you have two classes. But when I give just some data to the unsupervised learning approach, it will not know how many classes, leave alone the name. How many classes it should differentiate, it doesn't know. Then again, there is a problem. That concept is called as data mining. How you are going to derive information from one single data. That is also much more useful when you go for unsupervised learning. And to find out some structure of the data, if you say that, okay, I want to find out whether this signal has a peak amplitude at some specific time or some a low amplitude at some specific time. So once that structure is obtained, we can use it for maybe 30 years or 40 years, something like that. There are some applications like our electricity usage monitoring, automated electricity usage monitoring, whether which will be the peak time. When we come to the office, nobody's there in my home, then the usage will be less. If some model or some structure is obtained, then we can use it for a longer period of time. So for such applications, again, we go for unsupervised training approaches. So basically, like how we saw for supervised learning approaches, classification and regression, here unsupervised is used for clustering and association. Never ever forget this. Supervised, classification and regression, and unsupervised, clustering and association. What is this clustering? We have seen that in a sufficient manner just 10 minutes back, right? Categorizing the images or data, you can say, categorizing the data based on some similarity measures. Based on some similar, how do you categorize the data? How do you categorize a cat and a dog? Okay, they cannot walk like how human beings. Okay, let me put in the same category. Correct? Or domestic animals, they do not eat meat or something like that. They are grown, they are used as a pet in the house. Fine, you can put it in the same category. So that similarity measures are very, very, very important when you go for clustering. And association, discovering the probability of co-occurrence of items. How many of you purchased online products via Amazon? Amazon, Flipkart, anything. Right? Whenever you buy some shampoo in, I mean, order some shampoo, immediately you will get some details below. Have you observed that people who bought shampoo also bought comb, powder, perfumes, and all those things? Right? How do they find that? That is called as association. They do not know who used that. Right? If they would have known who used that, then it comes under the category of supervised. But here they are not bothered about, this application is not bothered about who used that, but it is bothered about how it is being used. Okay, so if this person is buying this, hundreds of people are buying this. Okay, then there is some relation between this. So if I advertise that, people may buy, my business may grow up. E-commerce comes under the category of this association. Right? So association and clustering do not talk about specific items, but they talk contents or items or applications generally. This is one example for clustering, right? Clustering, the phone call usage. Nowadays, you can see Geo announcing immediate free offers, then comes Airtel, BSNL. All these people are having a competition. That is almost a competition in a telecom company. So how many offers should I give? So how many people are using my stuffs? I am not interested in knowing who is using that, but I am interested to know how many are using that. So based on that, I can come to a conclusion for my business. So what will be the data in that case? Total calls and the internet usage. Nowadays, you can see that data pack and this voice call, everything come under the same category. So I will take the data, develop a model, and finally say these many users, right? Call duration is in x-axis, internet usage is in y-axis. So C, when you say take C, these people are a group of people who make use of calls more than your internet, because calls are on the extreme level. Right? When you take B, you can find that your calls are in the lower part. Internet is also in the lower part. So you can find out how many people, how many circles are there, and based on the circles, then you can come to a conclusion. Okay, I should have some offer for data pack, or I should offer some give some offer for voice call. You can decide something. So such type of applications comes under the category of unsupervised clustering. It is same as that of dividing your spoon and knife, but without knowing whose name is there in A, whose name is B, whose name is there in C. Just categorizing based on some similarity issues. Here similarity measure is long call or short internet, or long internet usage or short call. Right? That is the criteria on which we are going to classify. You take association, you can see the customer number one. He has bought bread, milk, fruits, and wheat. Customer number two, bread, milk, rice, and butter. Right? But the common thing is, if he bought bread, there is a high chance that he will buy milk. There are in retail stores in US, UK, and all the European nations are doing a great business on this. Nowadays, you can see in Amazon, right? And food, the fresh vegetables and all those. How boldly are they coming to business without seeing the customer, without talking with the customer? Machine learning is there. They are intelligent, right? They are taking our brain, they are taking our emotions, they are taking our data with the help of these machine learning approaches, and then they are making business. Then how boldly Alibaba, Jack Ma can spend those much amount of dollars in this e-commerce or online business? Machine learning is there. Scientists or researchers like you who are going to develop algorithms play a major role in making them rich, right? So unsupervised training algorithms are very, very useful when it comes to the association part in the online business or e-commerce. So depending upon the application, you can even in Facebook recommendation systems, right? We call it as recommendation systems. When I entered that I studied in so and so school, immediately all the friends, people you may know, how did they find that? Everything is based on this. They do not want who is going to do that, but they want somebody is doing that. That is the difference between supervised and unsupervised machine learning approaches. Advantages: quicker than supervised. Why? Distance education, you need not study all the 90 days. I'm not sure even when I teach how many are studying daily or how many are studying only before the exams. I do not know, right? I cannot monitor you. But generally, we say that supervised, you are studying for all the 90 days. And when you go for unsupervised, it's not necessary. In a distance education, you can study only the day before exam and still you can pass, right? That is also there. But the chances of failure is more in comparison with supervised. So we say that unsupervised training approaches are quicker but inaccurate. Supervised training algorithms or machine learning approaches are accurate, but they take more time because the error need to be made equal to zero. Disadvantages, as we have seen, you cannot get precise information. That's what I want to stress again and again and again. You will not know who is doing that, but you will know somebody is doing that. Less accuracy of the results because we do not have the target, no error. You cannot judge whether the system has learned your data or not. Then it is just based on assumption. User needs to spend time. As I told you, after categorizing or grouping your data, now if you want to again separate out spoon and knife separately, you need to spend some time in post processing and label the classes. That process also some people do that. That is also fine, right? But you need to have some additional time apart from the training process. Spectral properties of classes can also change over time. This is another important concept, right? We think that okay, spoon will always, or you can take a chair. A chair will always have a backrest and a handle, right? Now you go to your restaurant, right? You can see only a small top over there, right? Sometimes I will lose my balance. I'm not sure whether it is a chair or not, because when data are evolving, the properties also may change. So when you depend on properties, or when you depend on patterns, when you depend on shapes for categorizing or grouping the data, then you should be very, very careful. So indirectly, I am trying to say you that there are lots and lots of challenges with the machine learning algorithms and applications. That's why people are just running like that towards that. And the scope for improvement is also more. Right? Brain, God's creation, man's creation. Compare God's creation, do something in man's creation. That's all. Your machine learning is over. Applications, you can go for market basket analysis. You can semantic clustering means you are going to categorize based on some text data or some applications are there. Then delivery store optimization, what product should I have in my shop to make sure that it will be sold popularly by the it will be taken by the people. Then identifying accident prone areas, right? I am not bothered about whether who met with an accident, right? But 50 people met with an accident, then I will have a board. This is an accident prone area. Finding such things comes under the category of supervised. And this is a difference which you must know. When you say input data, it's a labeled data. When you go for unsupervised, it is not a labeled data. Computational complexity or speed, supervised, it will need more time. That means it's very complex. But when you go for unsupervised, it is less complex. Real time, mostly we go for offline analysis, but when you go for your unsupervised learning, we go for real-time analysis because we have the flexibility of having the target data. So you can use it in the offline mode also. Number of classes in supervised learning, I know this is spoon, this is knife. So the total number of classes are 2. So number of classes are known, but in unsupervised, if based on my similarity measures, I can categorize them into 4 or 5 or 6, depends. Accuracy is very, very important. Supervised, it is more accurate, and unsupervised, not that great in terms of accuracy. But still, you can use if you feel that your application does not demand that much high accuracy. It's a small example I want to give, right? Supervised learning and unsupervised learning. Supervised learning, I'm giving the duck images, right, to the machine, and along with the duck images, I am giving 2 other images. But the interesting thing you have to see here is those images also look like duck, right? So don't go for a machine learning application where your data is sufficiently different. You should not go for a machine learning approach for differentiating an aeroplane and a tiger. Aeroplane and tiger are already completely different. Then why much more complex algorithms you should go for? When a tomato is available in a shop nearby, why should you go to Coimbatore and buy a tomato? That, just to make things supernatural or something different, don't go for that, right? Complex application, that when all the data of yours are looking similar, then you can go for such. So I'm also giving not duck, not duck. I know this is something like a porcupine or something like a rabbit, but it looks like a duck. I can identify, but a machine may get confused. So this is a complex application where I'm also specifying the labels. Supervised learning learns the algorithms we will see from the second chapter onwards. Then it gives a model. It doesn't give a program, it gives a model for bird recognition, animal recognition, you can say. Fixed for only that. You cannot say that I am going to give a car image to that. That is nonsense. Ready. Machine is learned only those data. You give a data similar to that. Then when you go for supervised, when you go for giving a duck during the training process, it will say duck, or when you give some other image, if it is learned correctly, it will say not a duck. The same way in the unsupervised, when you see, I'm giving everything, but I'm not giving the names. When I give unsupervised learning, when it learns based on the similarity measures, right? Maybe based on the wings or the beak or the flaps, the first 3 ducks are categorized. Then I have rabbit in another category, porcupine in another category. A completely perfectly learned unsupervised model. It will not tell me what is what, but it will tell me these are under same category. So this is all about your unsupervised learning, which I feel you must know. You mark down all the technical words. So when you are using some application or something like that, definitely you will need that. When you understand that in the best possible way, then absolutely there will not be any issues for you to go into the application part. Let me mark the attendance quickly. You check your attendance also often, right? So that I should not have made any mistake. Don't come and tell me in the last moment, which will be very difficult for me. Amulya,
Yes, sir.
Judson,
Yes, sir.
Samyukta,
Present, sir.
Angel,
Present, sir.
Pavan, Pavan chat box. Okay. Abhinaya,
Yes, sir.
If somebody is typing in chat box, could you please let me know that somebody has given their names in the chat box, so it will be easy for me. Kiran Kumar,
The chat box.
chat box.
chat
Thank
box,
you.
sir.
Okay. Manideep,
Present, sir.
Bhanuteja,
Present, sir.
Jennifer.
Chat box, sir.
Okay, ma. Priyadarshini,
Yes, sir.
Afreed,
Present, sir.
Jayant,
Yes, sir.
Vikas.
Chat box, sir.
Okay, pa. Paul Finney,
Present, sir.
Bhuvaneshwar,
Present, sir.
Sumant Kumar,
Present, sir.
Ramesh Kumar.
Chat box, sir.
Okay, ma. Neeraj Kumar,
Yes, sir.
Zubair,
Yes, sir.
Kirti.
Chat box, sir.
Okay, ma. Dinesh,
Present, sir.
Tejaswant,
Yes, sir.
Chandana Priya,
Present, sir.
Karthik,
Yes, sir.
Vijay Kumar,
Yes, sir.
Jenish. Jenish. Okay, Jenish absent. Rex Vimal,
Yes, sir.
Harshavardhan,
Present, sir.
Uday,
Yes, sir.
Sakib,
Yes, sir.
Krishnan,
Yes, sir.
Praneeth Reddy,
Yes, sir.
Salomi,
Chat box, sir.
Libinson, Libinson, Libinson absent. Alan Joshua,
Chat box, sir.
Ronan Joshua,
Chat box, sir.
Sai Kiran,
Yes, sir.
Joshiba,
Yes, sir.
Shiny,
Chat
Shiny.
box, sir.
Okay. Jasmine, Jasmine Shiba,
Chat box, sir.
Celestine, Jayasuriya,
Yes, sir.
Joanna Paul,
Yes, sir.
Manasa,
Yes, sir.
Ashrita,
Chat box, sir.
Narasimha Reddy,
Yes, sir.
Puneet Kumar,
Yes, sir.
Shiny Rebecca,
Chat box, sir.
Joshua Victor, Nagakiran,
Yes, sir.
Suraj,
Yes, sir.
Monica,
Yes, sir.
Taufik,
Yes, sir.
Manideep,
Present, sir.
Dikshit,
Yes, sir. Present, sir.
Maria Angel,
Yes, sir.
Amrut,
Yes, sir.
Pavan Kalyan,
Yes, sir.
Sainath,
Present, sir.
Gautam,
Sir.
Jagat Chandra,
Present, sir.
Vivekananda,
Yes, sir.
Shashank, Shashank, Shashank absent. Sai Ganesh,
Yes, sir.
Gopichand,
Present, sir.
Ritvik, Ritvik,
Chat.
I typed in start box.
132. Okay. Please write your name also in your chat box if you're typing chat box. Solomon, Solomon Raj, Solomon Raj absent. Sudarshan,
Present, sir.
Sujit Kumar,
Yes, sir.
Suresh Kumar,
Yes, sir.
Sunny,
Present, sir.
Amrita Das, Amrita Das, Was she there earlier? Okay, absent. Okay, absentees, I will read out the names.
Sir,
Janish,
Amrita just left the meeting, sir.
she was there earlier in the meeting? In the
Yes,
class?
sir. Yes, sir.
Janish? Janish absent. Then Libinson absent.
Sir, present, sir.
Libinson present.
Oh, yes, sir.
Okay. Janish absent. Then Shashan absent.
Sorry, replied in
Sir, chat box.
Present, sir. Chat box.
Chat box.
Yes, sir.
Then Solomon Raj. Janish absent. Solomon Raj absent. Only these two people. Okay. Okay, ma. Thank you. Thank you for helping me in marking the attendance.
So can you tell me please to join the Google Classroom's link, sir?
Google Classroom link for what?
How to join for the code, sir, to join the class, sir.
I think it is with Manasa. Can you collect it from Manasa?
Okay, sir.
Okay.
Excuse me, sir.
Yes.
Sir, I'm not getting link in online portal, sir.
You are not getting a. What is your number?
URK 18EC 038.
038. Anybody else like that?
So 145 also, sir.
038, 145,
Sir, 124, sir.
124.
Yes.
Anybody else? Okay. If you have any doubts, you can ask me now, or otherwise you can leave the Google Meet.